Hello, this is our Introduction to Computer Science by Kason Lumpkin, Trindo, and Chris Chun. We're going to show you everything you need to know if you're considering a major in computer science. Let's get started. The IDEO design process. Using the IDEO design process, we started by trying to first get a good understanding of our end user. What was it that made them tick? Why did they choose the major they did? For those they hadn't for those that hadn't made a choice, what was it that they needed to help them take the next step? To better grasp what would be most compelling for helping a freshman or sophomore choose a major in computer science, we went out and asked our fellow classmates who are enrolled in computer science classes like Intro to Java Programming and Computer Science Principles what was the information they needed to help them make the decision and what information was ultimately most persuasive. So, what really matters? Our results from interviewing people showed, for some, knowing how to get the degree was most useful in helping them choose a major, whereas for others, knowing what career opportunities were associated with a given academic path was more useful. For those who were more driven by what career opportunities were available with a given major, it was essential that they were able to envision themselves doing the job and being happy and successful in their careers. Okay, how do I get the degree? What you need to know. This degree, awarded by Tacoma Community College, is designed for students who intended to transfer to a baccalaureate institution to major in computer science or some other closely related field. To satisfy the requirements for an Associate of Arts in Computer Science, you need to earn 62 general education credits, 20 to 22 core credits, and 6 to 8 elective credits for a combined total of 90 credits.
So, what would the next 2 years at TCC look like as a computer science major? This is what 2 years at TCC could look like for you. You could take 3 classes a quarter for winter, spring, and fall, and take 2 classes in the summer. Most people generally take fewer classes in the summer because it's only 8 weeks, whereas in the other quarters, you have 11 weeks. So it's almost like you have a whole month less to do the same amount of work. It can be very challenging. You'll need to work with your academic advisor to ensure you meet the requirements for the college you'll be transferring to. For example, if you plan on transferring to the University of Washington, any lab science like Bio 101 can be substituted for a second quarter physics class. This is especially useful if math isn't your strong suit. What type of degree should I get? Does it need to be ABET accredited? Accreditation Board of Engineering and Technology (ABET) assures confidence that a collegiate program has met the standards essential to preparing graduates to enter critical STEM fields in the global workforce. ABET accredited programs are important for an engineering undergrad degree, but not as important for a computer science degree. For example, although as the name may imply, an engineering degree is unnecessary to become a software engineer. Most people pursuing a career as a software engineer pursue a Bachelor's of Arts Science in Computer Science. Therefore, ABET accredited degrees are less important for computer science majors. In fact, many computer science programs at top universities like Stanford are not ABET accredited. Therefore, when considering a degree in computer science, it is most important to first consider what type of careers inspire you the most. What's out there? The future careers for those wielding this powerful degree remains bright. According to TCC, there are around roughly 90,000 currently employed holding a BS in computer science in the Tacoma-Seattle area. They have an average annual salary above 100,000 and have an expected employment growth of around 8.5% over the next 4 years. What are some subfields of computer science? Computer science is a vast field of study with many exciting career opportunities. People with a computer science degree may also pursue one of the following subdisciplines and focus areas to major in. Artificial intelligence. That's right, it's not just a buzzword. It's also a new and popular major at many universities, including the University of Washington. This degree is designed for engineers who want to advance their careers by applying modern AI and machine learning methods to their work, particularly for applications with physical constraints such as manufacturing, chemical processes, or robotics. In addition to gaining foundational AI and machine learning skills applicable to all engineers, students will complete domain specific training to learn state of the art AI and machine learning techniques specific to their field. Human computer interaction. This is also a new and popular major at many universities, including the University of Washington. By integrating several disciplines, the Master of Human Computer Interaction and Design program brings together design, technology, and the study of human behavior, creating students who can work seamlessly across these fields to create innovative new products, technologies, and services. This major is especially geared towards students who want to enter the workforce as a UI UX designer. Perhaps students who don't enjoy the technical aspects of computers but prefer to focus on how humans interact with them. Cybersecurity. A cybersecurity major can prepare students to protect organizations from cyber threats by teaching them about network security, data protection, and ethical hacking. Some topics covered in cybersecurity programs include network security. Students learn about common attacks on networks and virtual systems, as well as strategies to protect them. Digital forensics. Students learn how to identify cyber attacks, find and analyze evidence, and identify consequences. Data science. Data science is essential for cybersecurity because most cyber attacks are aimed at compromising an organization's data.
So, what kind of job that I could get? So, you take a look at the software engineering. Software engineering, they usually design, develop, test, and maintain the software application and the system to solve the real world problems. And the cybersecurity engineering, as they are they are IT professionals who protect organizations, protect computer networks and sensitive data from the attacks. The developer builds the website and web applications using variety of the program language, the framework, and all the technical tools. AI ethicists, they play a role in ensure that AI systems are developed and deployed ethically. The cloud architect is an AI IT professional who manage an organization cloud computing system. The UI designer, like they create a graphically tweaked interface for the website, app, or device that user interact with. Generally, they specialize in human interaction. So, what's going on the locally? So let's talk about the academic research project. Like in Western Washington University, new electrical and computer engineering, energy science, and computer science building. Kaiser Bursary Hall, which provides a state-of-the-art teaching space and is experiential learning environment. The University of Washington Computer Science and Engineering programs offer rich research opportunities in areas such as artificial intelligence, machine learning, and computer and network. So we have the industry project. The Microsoft research on intelligence and machine learning in Redmond, Washington. Amazon research on computer science, computer vision, and robotics in Seattle, Washington. Google research on the natural language processing and machine learning in Kirtland, Washington. And the last one that could be the government project. The Washington State Department of Transportation research on intelligent transport system. The Washington State Department of the Ecology research on environmental monitoring and modeling. The City of the Seattle research on the smart cities and urban planning. What
How will AI affect my job? Large language models can write software, so you're wondering, will AI replace programmers? The answer is no. In fact, AI will create demand for even more programmers. Programming is not just about writing code. The essence of creating software lies in creativity, defining problems, breaking them down, troubleshooting, and effective communication. These are intricately human skills that AI is yet to replicate. Essentially, a programmer's most valuable asset isn't just coding, it's their ability to think and innovate. Good luck. Now go out there and make the dream come true.